Welcome back. Okay, so right now we're going to talk about Module 3, Topic 3, Lesson 2, Talk the Talk. It's on page 496 in your textbook. So number 1 says plus or times. Describe the similarities and differences between the pairs of equations. So pause the video, please, and take a second to look at them and see if you can figure out what's different. And we'll compare this column with this column. Go ahead and hit pause, please. Okay, so hopefully you've come up with some kind of ideas. So when I'm looking at them, first thing I would do is just kind of read each of them. So with y equals 5x, then it says and, so almost like it wants me to compare here as well. Y equals x plus 5, then y equals 1/2 x, and y equals 1/2 plus x, y equals 4 and 95/100 x, and y equals x plus 4 and 95/100. So the first thing I notice is everything starts with a y, and it has an equals. And then on the other side of the equal sign, like here I have a 5 and here I have a 5. I have an x in each. Here the x is connected with multiplying. Here it's connected with adding. I have 1/2 and 1/2, and also x's. Oh, again, it's connected with multiplying and connected with adding. 4 and 95/100, and it's multiplying here as well. And adding is here. You guys are going to get to see my kitty today. So I guess the equations on the left all show a multiplicative relationship. We'll just continue. But those on the right show an additive relationship. Now this is the differences. The similarities, kind of pointed out in the very beginning. They all have x and y variables. And each pair uses a common number. Go ahead and pause so that you can get that written down before you move on to number 2, please. Number 2 says, describe the similarities and differences among the graphs shown and write an equation for each graph. We're actually not going to do that part. This text has not given us enough tools to be able to do that for some of these. A and B we can probably do. C and D, they haven't really given us enough tools to be able to do that just yet. Okay, so for graph A, I noticed that that is the only one that has dots. Do you remember what the dots are? What kind of graph that's called? If it's pointing out just individual specific dots, whereas this line indicates all of the points along this line and all of the points that would continue, and the other three all have that. So what is it called when we point out just specific locations? You know yet? It shows discrete. Did you have that answer? Points. All others are, what's the other word? We have discrete and continuous. Can you guys hear my cat purring? She purrs so loudly. Okay, so let's see what's happening in each of these graphs. So for graph A, I notice that it starts at 0, 2. So when x is 0, y is 2. And then when, I'm going to actually write that down. I'm going to make myself a little xy table here. Please do the same thing. So when x is 0, y is 2. When x is 1, y is 3. 2 and 4 over to 3, 5, and then we have 4 and 6. So it looks like all of these, we're going to set up our equations like number 1. We're going to have a y equals. See, it looks like every time my y increases by 2. So if I said x was 0, then I add 2. Let me see if that works. Add 2 to the x. So if x is 1, 1 plus 2 is 3. 2 plus 2 is 4. 3 plus 2. Okay, so that works. So my equation there is y equals x plus 2. And what about for b? So this is additive, right? And then what about b? Oh, it looks like b is the same thing. When I mark some exact points on the line, I get some of these same points. So I have 0, 2. I still have 1, 3. I have 2, 4. So they're all the same. So my equation is still y equals x plus 2. So it's still additive as well. This one's also additive. So is this one. So the only difference here is this one is discrete, which means the answers for whatever the scenario is are just the whole numbers, while in this one, the answers could be any of these numbers in between here as well. So this one might talk about specific number of items, like number of cookies, where this one might be about dollar amount or time down here on the X, something that could be continuous. So letter C and D, these don't really cross at very specific points, and the graph isn't really detailed enough to show me where they do cross. I see this one. So there isn't a clear pattern in that one. And there isn't in this one either. In fact, like there at the 1, it looks like it crosses at about halfway. Here in this one, it looks like it crosses about halfway. So again, this isn't something that I would expect you to see on this one, because if we had a graph that was larger and more detailed, then yes, we could probably figure it out. This graph isn't detailed enough for us to know the exact location of these points on the line where it crosses. But it looks like this one, because it has an XY of 1, and what I'm going to guess is about 2.5, and then 2, 5. If I were to write an equation just from these graphs, it looks like it's going to go up by 2.5 as the x value increases by 1. It looks like the y value increases by 2.5. It'd be nice if that graph was bigger so we could actually see it. So it looks like it increases by 2.5. So that would, I wrote that as a fraction. Y equals 5 halves x, or y equals 2.5x. Either one would be fine. So that's a multiplicative relationship. And graph D, we still have 0, 0. I guess I could have put that in there as well. By the way, you don't necessarily have to list those in order in an XY table. And we call that a T table because here's the letter T. T table. Okay, so I said it looks like at 1, it's at 4.5. I don't see where it's at 2. Half of 4.5. If I were going to look maybe here at a half, I was going to try to look at 0.5. 0.5 is that about right there. Half of 4.5 is 2.25. I guess that looks like that could be 2.25. If that was the case, and again, this graph should be much larger for us to actually know that. I'm not real happy with the way they present this. It looks like we would be increasing by 4.5 looking at the whole numbers. We would have to divide. We went to half of that, so we'd have to divide each of those by 2 to figure out the halfway point. But we're just going to look here at where it's a 1, just like we did over here, where x is 1. So y equals 4.5 times x. Again, similarly like that, you could write it as 9 halves x, which is still multiplicative. Okay, take a minute, get that all written down, please.